Welcome to vectors. The objects that finally decided numbers alone were too boring. Scalars only tell you how much. Vectors tell you how much and which way. So they are basically numbers with a GPS. Where the vector sits does not matter. If two arrows have the same length and point the same way, they are equal. Vectors are very chill about location. The vector begins at the initial point and ends at the terminal point. Basically an arrow. The zero vector has length 0, so direction does not really make sense. It is the vector version of doing absolutely nothing, but mathematically. This is the parallelogram rule. Build the parallelogram, then the diagonal is the sum. Geometry loves construction projects. Whether you use the triangle rule or parallelogram rule, the same sum appears. Also, order does not matter for addition. Unlike socks and sandals, some things really do commute. The negative vector cancels the original vector. Same size, opposite direction. Like two equally stubborn people pulling in opposite directions and getting nowhere. Subtraction means add the opposite. Geometrically, it also tells you how to get from one vector endpoint to the other. Multiplying by a negative scalar is very dramatic for a vector. It's becoming the exact opposite. Multiplying by a positive number stretches or shrinks the vector. Multiplying by a negative number both scales and flips it. Associativity means grouping does not matter. You can add the first two first or the last two first. The vectors do not care about your parentheses. Geometrically, you can use tail-to-head method as indicated in the graph. Once the tail is at the origin, the vector is completely described by where it ends. Coordinates become the vector's home address. A 3D vector needs three components as the name suggests. Now we need x, y, and z to know how long the arrow is and in which direction it points. To check if vectors are equal, compare component by component. This is like checking a password. Every character must match, not just the vibe. Equal vectors mean equal components. So we just compare slot by slot. This is one of the rare moments in math where being picky is actually the whole method. To get the vector from one point to another, subtract starting coordinates from ending coordinates. Destination minus departure. Airlines could learn from this clarity. End point minus the start point. If you reverse the order, You get the opposite vector and a sad wrong answer. Reversing the points reverses the direction. Same road, opposite trip. The vector turns around and drives back home. In Rn, we stop drawing pictures and start trusting notation. Past 3D, geometry becomes a place where imagination files for overtime. All vector operations in Rn are done component by component. It is the mathematical equivalent of working through a grocery list one item at a time. Every operation here is just component by component arithmetic. Nothing fancy, but lots of places for tiny mistakes to sneak in like algebraic raccoons. These are the basic algebra rules for vectors. Same spirit as regular algebra, except now every number brought its entire directional baggage with it. Multiplying by 0 kills everything, even vectors. And multiplying by -1 flips direction. Scalars really act like control freaks. Treat vector algebra like regular algebra. Distribute, combine like terms, stay calm. The letters are vectors, but the cleanup job is still algebra with better posture. This works just like solving an equation with ordinary variables. The only difference is that a and x are vectors. A linear combination means building one vector from other vectors using scalar multiples and addition. It is basically vector cooking. Choose ingredients, choose amounts, stir. To write a vector as a linear combination, introduce unknown coefficients and match components. We are basically turning vectors into a system of equations wearing a disguise. Once we match components, the vector problem becomes a linear system. And when in doubt, Gaussian elimination comes in like the janitor of linear algebra. We make the first pivot nice, then clear out the entries below it. Gaussian elimination is just organized destruction with excellent manners. The last row becomes 0, which is fine because the system is still consistent. Then backsolve and we get the coefficients. The vector has confessed its parents. Today the big ideas were direction, magnitude, components, and vector operations. Once vectors become coordinates, the geometry and algebra shake hands. Beautiful, efficient, and slightly intimidating, like a well-dressed ninja.